Hello, welcome to CM Square Learning Center. In today's chemistry lesson, I'm going to talk about this MC questions. It's about emission spectrums. So these two MC questions is from my IB past paper 2017 May SL paper time zone 2 and time zone 1. Time zone 1 question 6 and time zone 2 question 6. The first one, which electron transition in the hydrogen atom emission spectrum emits? So that's the keyword, emits radiation with the longest wavelength. So the second part is longest wavelength. So first of all, you should know the emission spectrum of a hydrogen atom. It's like this. The energy difference between two successive energy levels becomes smaller when n increase. So n equals 1, 2, 3, 4, 5, maybe infinity. Yeah. And the energy is increasing. That's the y-axis. Yeah, there are so many electron transition from high to low energy level. So maybe from 2 to 1, 3 to 1, 4 to 1, 5 to 1. Maybe 3 to 2, 4 to 2, 5 to 2. Or maybe 4, 3, 5, 3, and maybe 6, 3. Yeah, that's a lot. And for all the electron transition from higher to the first energy level, the radiation is UV, and the second one is visible, and the third is infrared. That's the key thing you should know in SL syllabus. So let's look at these questions. Emit radiation. So sometimes the MC question will ask absorb radiations. Emit radiation is go down. Electron transition from high to low energy level. Where absorb radiation is go up from low to high energy level. So let's look at these four choices. Now we have to choose the one with higher to lower energy level. So we have to eliminate answer B, because that's from first to second energy level is absorptions. So now we have answer A, C, D. And let's look at the second keyword of the question, longest wavelength. And the second key thing you should know is the relationship between energy, frequency, and wavelength. Energy equals Planck constant times the frequency. So that means energy is directly proportional to the frequency. Higher energy, higher frequency. The second formula is energy equals Planck constant times the light speed divided by the wavelength. And energy is inversely proportional to wavelength. So which means higher energy, shorter wavelength. Or lower energy, longer wavelength. Yeah. Now we have to choose the one with longest wavelength radiation. So wavelength increase, energy decrease. So that means we have to choose the one with smallest energy. That means the shortest distance. Let's compare A and C, because these two is all fall back to n equals 1. From 2 to 1 and 4 to 1, of course, 2 to 1 has a small energy gap because the distance is shorter than 4 to 1. So now we can eliminate answer C. And now compare A and D. 2 to 1 and 3 to 2. That's 2 to 1, and that's 3 to 2. Of course, 3 to 2 has a shorter distance, so it will emit lower energy. That means longer wavelength. So the answer is 3 to 2. Answer is D. And the second question is a 17 May paper 1 time zone 2 question 6. And let's look at the questions. Which electron transition emits radiation? The same, emit radiation with longest wavelength. So it's all the same as the question 1. We know emit radiation means falling from high to low energy level. So we can eliminate answer B and answer D, because these two is going up absorb radiations. And longest wavelength means lower energy. So lower energy means shorter distance. A and C. Of course, C has shorter distance. You can find it from the picture here. So answer is C.